today I want to talk about level of significance in relation to your type 1, your type 2 errors. Come on, let's get started here. Alright, I'm on page 337, somewhere around there. So now for your level of significance, in a hypothesis test, we compare and we're going to find the probability under your curve to an actual value, and we call this value your level of significance. To decrease the probability that you will reject a null hypothesis when it's true, this is your type 1 error, and we only deal with type 1 errors, you can lower your level of significance. So if you keep a very small level of significance, you keep it down to a very small possibility or probability that you actually reject the null when it's true. That's the only type error that we look at. If you remember your chart, if you reject the null when it's actually true, that gave you a type 1 error. That's all we look at. The type 2 error is listed as a beta. We call this type 1 R alpha, and the other one is beta. If you lower alpha, you usually kind of raise beta, but we don't do the beta test at all in here. You're still just like the first year of statistics. Again, this is a whole another field of study. If you go into statistics, is anybody going into the field of statistics? No? It's a really, really interesting field. I mean, really interesting. And actuarial work, any of that kind of work, predictions, forecasting. It's really a cool field of study. Okay, so we're going to set your level of significance. It is the maximum allowable probability of making your type 1 error when your null hypothesis is rejected when it was actually true. That's our type 1. It is denoted by this symbol, and this is called alpha. The probability of a type 2 is beta, which we don't really address. By setting your level of significance small, and generally these are our level of significance, 10%, 5%, 1%, the probability of rejecting a true null hypothesis will be small. We want that error to be very small. Okay? We don't want to take a chance that we'll reject the null when it's actually true. Since your level of significance is the maximum allowable probability, one way to decide whether you're going to actually reject your null statement or not is to determine the probability of your z-test or your t-test. Look at your area under the curve and compare it to your level of significance. We test your p-value to your level of significance. And we'll talk about this soon, but this is how we'll test this. And if it's less than our maximum allowable, we'll reject the null. If it's greater than, then we'll fail to reject. And we have a series of things that we walk through whenever we test. And I kind of put that on your chart as well. So your p-value, the value that we get, is your probability value. Your probability value comes from under your curve, the area under your curve. So we technically find your z-score. We call it a test statistic, or a t-score, or a chi-square, whatever your test statistic happens to be. We look at the area under the curve associated with it, and we compare it to your level of significance. That's where we're headed with our testing. It doesn't make a lot of sense now to you, because you're just kind of hearing the blah, blah, blah part, but as soon as we start doing this, it'll start making more sense. Your p-value, your area under the curve, depends which part of the curve you're looking at. You go to the left, to the right, in the middle. So therefore, we have a series of tests that we do. And remember what I told you earlier, that your test depends on your alternate hypothesis, your HA. The tail of your test depends on your HA. So say, for instance, my HO says that my mean is greater than or equal to 10. My HA will say my mean is less than 10. Now, when we do this, say, I'm just going to put it here. Say this is 10. We're looking at, well, let's make this 10. We're looking at this part right here, less than. We're always following the tail of the HA. If it says greater, we're going the opposite way. If this is where 10 is, we're going the opposite way. If it's a two-tail test, it's an equal, and we have two tails. We put it in the middle. So depending on which way your test is, which way your HA is, depends where you test. And if you remember back on your Z-scores and your T-scores, whenever you look it up, it's always the area to the left. The chi-square is the only one that goes to the right. Everybody else goes to the left. So most of the time we'll be going to the left with your tests. Now, the smaller the p-value, the smaller the probability, the smaller the area under the curve, bless you, the more evidence there is to reject the null. I need you to think about this for a minute. If there's a very small probability that that's going to happen, then we're going to say reject the null. A very small p-value indicates a rare occurrence, right? Isn't like if it's less than 2, less than -3, so whatever that is, there's your very small occurrences. It kind of fits into the scheme of your curve. So take a look at example 3. It always helps once we walk through some of these. They want us to identify the HO, the HA, then just determine if it's a right-tailed, a left-tailed, or a two-tailed, and sketch the value. So we're just going to walk through this and sketch where your p-value might be. A university publicizes that the proportion of students who graduate in 4 years is 82%. So, how do I set up this plane? This is my plane. Good. P equals 0.82. So, this is a one-tailed, a left-tailed, a right-tailed, or a two-tailed. If it's equal, it's a two-tailed. If it's equal, this is a two-tailed test. Is this the HO or the HA? HO. So what would your HA say? Good. This is going to be a two-tailed test. In other words, it's going to look like this. If you take a look at, I don't have the picture, I thought I did up here, but if you take a look at page 338, take a look at page 338. See their curves? See all the curves for those? See the left tail test? It's shaded into the left. The right tail test, shaded into the right. A two tail test, shares. It's going to share your probability. It's going to be split in half equally because it's symmetrical. Okay? All right. Let's try another one. All we're doing now is just setting them up, determining what tail they're going to be. Unfortunately, you don't really get to see how we use it yet until we give you all the definitions of everything. A water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than 2.5 gallons per minute. The mean is less than 2.5. This is the claim. Is it the HO or the HA? HA. So what tail test are we going to have? A left tail. This tail points to it. Points to the left. We're going to have a left tail test. Somewhere here. This is your HA. Your HO, its complement, U, is greater than or equal to 2.5. We use the tail of your HA. That's really, really important. If anything, just get that part right now, because you really don't see how we use a tail yet. A cereal manufacturer advertises that the mean of its 20-ounce cereal is more than 20 ounces. So U is more than 20. Is this HO or HA? HA. What tail test are we going to have? A right tail test. Good. What's the HO? Good. Less than or equal to 20. Okay, so everybody sees where we're going with that? Okay. We're just kind of setting these things up. Hopefully soon we'll start working with them. I'd like to just get through the rest of the definition things today so that it starts to make sense when we work with it tomorrow. Or maybe Monday, by Monday. So to conclude a hypothesis test, when you have to make a decision about all the data that you just collected, the tests that you ran and everything else, you make a decision and you interpret your decision by either rejecting your null hypothesis or failing to reject your null hypothesis. Now, when we do that, remember, we don't say if it's true, we don't say if it's false, we don't say if it's good or bad, we just say reject the null, fail to reject the null. In your head, the easiest way to do it is think, this is not good, I'll take this one. I'll accept this one, I won't take this one. In your head, you'll walk through that, but on paper, we either reject the null or we fail to reject the null. One of your biggest tests is right here for your p-value. If your p-value, this is the area under your curve, is less than your level of significance, you're going to reject your HO. If your area under your curve is greater than your level of significance, you're going to fail to reject your HO. Now, this next chart I gave you on that handout that I had the other one on, the type 1 and the type 2 errors, I gave you this chart. We're going to live with this chart. I'm going to put it up around the walls too. Because whenever you test something, your last statement comes from here. Comes right off of this chart. So say you do all your tests, you found your test statistic, your p-value, you compared it, you blah, blah, blah. You found your claim was HO. You rejected HO. This is the statement you're going to have to give. So if your claim, in other words, if I claim that my cereal is more than 20, greater than or equal to 20, let's say, 20 ounces. This is my claim, this is my HO. This is my HA. So we do all this testing and we said reject the null hypothesis. I don't really like this. I like this one instead. So we come here. Your claim is your HO. We rejected your HO. This is our answer. There is not enough evidence, there is enough evidence to reject the claim that the amount of cereal was greater than or equal to 20 ounces. This is how we set up our final statement. So all the testing that you do, it comes down to this one little box. So say it was the other way. Say this was the claim. Then you come here. Your claim is your HA. If you rejected your HO, that means if you didn't like this one, you liked this one. So therefore you say, if my claim is my HA and I rejected my HO, there is enough evidence to support the claim that the mean ounces of cereal is less than 20 ounces. So we're going to use this chart all the time whenever we test. The last thing we do is go to this chart. I put that chart on your type 1, type 2 errors. I give you a copy of it to keep handy in your notebooks. So that's how we're going to be testing. Granted, you don't see the test yet, but that's how we're going to do our little test. So just as you look through this, when you perform a hypothesis test, keep your chart handy next to you. You perform a hypothesis test, and the claim was the HO. A university publicizes, we just did this one earlier, right? And you want to, what is they're asking me to do? Ask you to interpret your decision if you reject. Okay, so let's go back to this. Here, this was my HO. P is equal to 0.82. P is not equal to 0.82 is my HA. Try to keep your hypothesis together so that you can know if you're doing one or the other. So, if you reject your HO, here's this. This is my claim. Follow your chart for this. Watch. My claim is my HO. You're in this column. Agree? You rejected HO. You're right here. So you meet right here. There is enough evidence to reject the claim that the proportion of students who graduate in 4 years is 82%. That's how you're going to have to get your final answer. Now, flip side, did not reject. Do not reject HO. HO is my claim. Do not reject HO. Fail to reject. There is not enough evidence to reject the claim that the proportion of students who graduate in 4 years is 82%. There's not enough evidence to reject the claim. There's not enough evidence to support the claim. We never say it is good, it is bad. We just say our evidence shows that at this point we reject this claim. Our evidence shows that at this point we did not reject the claim. So you never actually make a statement about your findings other than do you reject, do you not reject the HO. If the claim is the HA, notice the difference here? These are really, really important. You use the word reject versus support. HA always uses the word support. HO uses the word reject. So see the difference in your table from doing this? Okay? This is really, really important. If anything, just like kind of catch this part. Now, probably this is all I need to tell you about, because as soon as we're done with this, we're going to actually go into testing them. Now, you state the claim mathematically and verbally. You identify your null and your alternate. You specify your level of significance. The problem will tell you your level of significance. It's generally 0.01, 0.05, 0.10. You determine your standardized sampling distribution and you sketch it. If it's a less than for your HA, it's a left tail. If it's a greater than for your HA, this is all based on your HA. It follows your tail. You calculate your test statistics. If it's a z-test, we'll calculate your z-score. If it's a t-test, we'll calculate your t statistic. If it's a chi-square, we'll calculate the chi. You find your p-value. Your p-value is the area associated under your curve. So once we do all this, then we make a decision. Then we say, is it less than or equal to your level of significance? We reject. If it's not, then you fail to reject. Okay? So that's what we're going to be looking at. All right. Also, what happens is, I was telling you the other day, it depends who makes this claim. There's a big difference on who makes the claim. If you look at the top of page 342, here's good strategies for when you're actually setting up your claim. In the courtroom, the strategy used by an attorney depends on whether the attorney is representing the defense or the prosecution. In a similar way, the strategy you use when you set up your hypothesis test should depend on whether you are trying to support or reject a claim. Remember, you cannot use a hypothesis test to support your claim if your claim is the null hypothesis. The only support words come for your alternate hypothesis. So as a researcher, if you want a conclusion that supports your claim, you have to make your claim worded so that it doesn't have the equal sign, that it fits the alternative hypothesis. if you want to reject your claim or fail to reject your claim, you have to make sure you set it up with the equal sign so that it becomes the null hypothesis. You can't switch those words at any time. So what this is saying is it gets a little tricky on how you would set this claim up. So a medical research team is investigating the benefits of a new surgical treatment. This is the medical research team investigating. One of the claims is that the mean recovery time for patients after this new treatment is about 96 hours. How would you write your null and your alternate hypothesis if you were on the research team and you wanted to support this claim? Your final answer is going to be, I support this claim or I fail to support this claim. How would you set up your claim? It's going to say about 96 hours. How would you set this up? If you're the research team, you
equals 96.
Well, equals is a difficult one because equals will give you an HO.
Okay, well, this is about 96 hours.
Yeah, right. So how are you going to set this up so that when you use the support word, it has to be an HA? If you say equals, it gives you the reject words. And you don't want to say not equals. I don't want to say it's not equal to 96. That's what I want to say if I was the medical research team. But how do you say about equal?
Equal is really about.
No, we can't say that. We only have the choices of equal, less than, greater than. Well, you only have the choice for HA of not equal, less than, or greater than. So you would want to say less than. You're the medical research team. Do you want this recovery time to take more than 96 hours?
Yeah.
No. You're the research team.
Okay, what?
Get him out of
Okay.
here.
Okay, guys. Listen. Okay, listen. I'm on the medical research team. I'm researching this new treatment. Is it really a good treatment if it takes my patients more than 96 hours? Or is it a better treatment if it takes them less than 96 hours to recover? Less than 96 hours. So,
Isn't that what I said?
more. You said not equal to. About. Okay. Taylor gave me the less than. Okay, so if you're on this medical research team, you're supporting this. You just developed this. You obviously make something so that your patients recover quickly. So if I want to use the support words in my final claim, I cannot have an equal sign in my claim. Therefore, this is my claim. This is my HA. So now, when I go to my chart, and my claim is my HA, I will use my support words. Okay? If you are the opposing team, you don't like this medical research team. You wanted to be the first one to do this. You want to cut their project apart.
Yeah.
And you want to reject their claim. How would you write their claim?
Their claims.
Greater than or equal to 96. So now your claim is your HO, and you're actually using the reject words. Do you see what we did here? There's two ways to look at this.
When we get close.
Well, right now I would like you just to try to understand it. We really haven't done any work with it, but really we haven't done any work. That's the hard part. You haven't worked with it yet. I'm only trying to break down all the parts for you. And it's hard to break down the parts when you don't do an actual example with the whole thing. But do we get this part? Okay, let's try another one. Okay. All right, I want, guys, chemical company that is being sued for paint damages to automobiles. You represent this company that's being sued. you want to support the claim. So if I use the word support, is my claim going to be an HO or an HA? HA. That's what uses the word support. You want to support the claim that the mean repair cost for automobiles is about $650. How would you write the no and the alternate hypothesis? Would you come up with, Donna? What's your claim?
Put U is less than 650.
Good. Okay, now, U is less than 650. You are representing this chemical company. They're saying it's about 650. So you don't want to say it's going to be more than, right? Because that makes it not sound too good for you. You want to say it's going to be less than. If I was the opposing one, if I was the one that's saying, hey, you damaged all my automobiles, I'm suing you. If I'm the one suing you, I'm going to say it's more than 650. I don't want to support what you're saying. I want to reject what you're saying. So it depends who sets up the HA, the HO. The first thing you have to do, guys, is look at the reject word and the support word. Tomorrow what we're going to do is get started on working on these. I was trying to break down the pieces for you, and it's very difficult when you don't see a problem in front of you. But one year I did try it the opposite way, and I skipped this whole part. It was very difficult then to explain piece by piece when everybody's just trying to say, just let me get the answer, just let me get the answer. So unfortunately, I kind of have to walk through this